Excellent. Very good. Well, thank you for inviting us to present at this event. My name is John Pearce. I'm the Chief Commercial Officer for Lacuna Space. I joined the company 3 years ago as the company was making the transition from theory to commercial service. And my job is to engage users of the constellation and develop valuable use cases. So my presentation today will be quite brief. So it's a very quick overview of the company. I'll do some quick introduction, but then my main theme for the content of the slides was to make some comparison against the slides I've seen previously for the UNISEC Common Mission Proposal, and to give some feedback from industry, from our professional experiences, and hopefully give some validation to assumptions and statements made in those slides. So to introduce Lacuna, so our role is to connect the unconnectable. The majority of the planet is outside of terrestrial coverage, maybe 80, 85, 90%, depending on how you measure it. And that makes it a hugely enjoyable task and role. To be out there finding all of these remote use cases, things that haven't been connected before and would benefit from some automation of bringing data back to the cloud. And that's what we do. So we're a relatively small company. Let's focus here on the people. We're about 20 people. This was a company meeting. You can see we like the color purple in all of our slides and our clothes. And I think within this group, I counted 8 different nationalities. So our main office is in the UK, and we also have Dutch and German offices as well. But this is our campus in Harwell. Well, it's not our campus. We're members of the campus. This is a space cluster. And within the campus, we have all the big agencies, the European Space Agency, UK Space Agency, Satellite Catapult. But this is a great location for us in the heart of new space in the UK, partly because of those supporters, these agencies, but also our supply chain is based here as well. So we're able to use facilities and services of other companies, and that's how such a small company as us, 20 people, can, build and operate an IoT constellation. So very briefly, the summary of what we do is we provide an IoT service. It's a global service of data acquisition, and we're here to enable all of those systems integrators or solution providers out there who are developing valuable solutions for IoT for all the different use cases to adopt satellite technology with this new low power capability that we have. And the focus of the style of engagement we have is typically use cases taking hourly readings and delivering to the cloud at least once a day, something like this. So as mentioned, I looked back at some of the previous UNISEC's slides on this topic about the IoT mission. And I'm just going to use these to make a kind of comparison and contrast against the Lacuna service. It feels like this is a good way to introduce us. So let's jump into that. So there was a slide talking about a variety of use cases, and Maximilian talked about more today. And I could pick any of these and say Lacuna has customers doing these kind of use cases. But I thought the most fun and unusual one is this elephant tracker, which was shown in your slides. And this is a project which we have done, I think, several years ago. I can't remember quite when. This is in Kenya, I believe. The company, the partner who did the trackers was Smart Parks. The developer was a company called ERNAS, and you can see there the tracker in pieces on the bench with a Lacuna satellite antenna. And the picture on the bottom left is an elephant really out there wearing this tracker. So I could do this for any of the use cases. I think we have examples of all of these, but it would be repetitive. But certainly environmental monitoring, lots of use cases around water and water quality. Agriculture is a big one. But what I hadn't seen here that Lacuna is focused on in industry are utilities. So electricity grids, renewable generation, water distribution networks, and metering. These are big use cases for us. I guess also remote infrastructure such as bridges, highways, oil pipelines, and such things. The next slide I saw from UNISEC talked about the store and forward architecture, and it looked very much like a slide which I put up here from Lacuna, which is a similar architecture, store and forward, but critically we're very much interoperable with the terrestrial LoRaWAN ecosystem. So we're making a hybrid solution where we extend the coverage of existing terrestrial networks for those use cases which normally would fall outside the economic coverage of a terrestrial network. So we don't break any of the existing investments or infrastructure that's been deployed. We just add data to it, which we bring back via satellite through the Lacuna routing platform. Our satellites are based on an SDR payload. We're about 6 years into this journey. We're on our 5th generation of payload. Each generation improves. Our most critical parameter of the payload is capacity. So, of course, a satellite antenna has a huge footprint and may have millions of devices falling within that footprint. So the capacity of the receiver is absolutely critical to the success of the mission. And because of this, we use LR-FHSS modulation, which is a kind of 2nd generation LoRaWAN. The original LoRaWAN chipsets use chirp spread spectrum, but it doesn't have the efficiency that we need. And picking up on a point which was mentioned before, we do cover all of these ISM or SRD bands around the world, from 863, 865 for India, 868 for Europe. The satellites, they switch bands as they go over continent to continent automatically. So we have profiles for each continent. And we've flown successfully 10 payloads over our 6 years. And we also supply the payloads to other people's constellations as well. So the picture on the bottom left is the SDR itself. The picture in the middle is the SDR with the deployable antenna in a stowed position, the small volume for launch. And then on the far right-hand side, the helical antenna is deployed, which of course is normally pointing down from the satellite. I saw in your slides talk about the size of the satellite being in a range 3U to 6U, and the previous presenter was talking about a 1U satellite. Lacuna satellites have been in that same range of 3U to 6U. Our current generation is actually 4U. That's where we've settled right now. There was a data rate written there of 300 to 500 bits per second. That we're in the same kind of range, 488, but it's important to note that when you take into account the headers and the redundancy in the packets, the user payload is much less, 46 bytes. It was mentioned earlier, 40 minutes contact, and I wasn't quite sure what the assumptions were there because we normally calculate 1 or 2 minutes contact at any single point. I suspect maybe 40 minutes might be the contact within Japan as a whole, I'm guessing.
40 minutes is frequent ground station passes.
Okay.
Maybe per day, the maximum time you can communicate with the satellite.
Okay. Yeah, for us, 1 to 2 minutes is for the sensor contacts. The satellites are traveling at 7,000 meters a second. They go horizon to horizon in a couple of minutes. And that's your opportunity to sync the data up to the cloud. So again, a big theme from the UNISEC presentation is about the constellation. You know, one satellite is some use, but you need a constellation to really be valuable. So I include a diagram here of a single satellite, and by the way, these are 500-kilometer LEO orbits, and they're polar orbits. And I noticed that was a discussion within the previous debates with UNISEC about having inclined orbits or polar orbits, and Lacuna is certainly using polar orbits. We are currently selling capacity on 6 satellites, which are actually distributed across 3 planes. And with this, we very comfortably provide this daily service. We also make our payloads available to other people's constellations, and this is the public list. There are also more on the list which are not yet public. But DS Telecom is a Portuguese company, Kispa is in the UK, OneWeb is French, European, and Omnispace is a US-based company, which is actually in MEO orbit, 10,000 kilometers, and that's in a 45-degree inclined plane as well. So on the next point on the UNISEC slides talked about ground sensors and the fact that they can be developed over time after the launch of satellites, and that's very true. This is our core reference design. It's a direct sensor to satellite, and this is all based on LoRaWAN technology. The majority of the DNA in that device is the same as any terrestrial LoRaWAN device. The key difference being the upward pointing antenna, which happens to be 8 by 8 centimeters. And of course, as mentioned, it uses LR FHSS modulation, which terrestrial networks have not yet adopted. And we also synchronize with the constellation. So the devices on the ground are conscious of the orbits of the satellites. And for us, that's critical for the ultra low power operation to keep the devices in sleep most of the time. But our route to market is very much open source. So the device you saw on the screen is our starting point, our reference, our known good reference for people to experiment with. But our customers always need some special sensor or special industrial design for one use case or another, like the elephant tracker. In this case, the one on the screen is a water level sensor using radar. So that radar is on the bottom of the unit and points down towards the surface of a reservoir or river. And this is how we go to market. We help IoT device makers add satellite capability to their own devices. And it's mass market interoperable. So there was a comment, I think, that the UNISEC proposed a 3 by 3 centimeter module. We use any of the LoRaWAN modules on the market, which I think the smallest, the Murata, is in the region of 1 by 1 centimeter. And there's this comment about the frequency band mentioned here, 920, which is the Japanese band, and the benefit this gives you to be license-free around the world. A really important bit of feedback from our experience. This was the basis of our business plan as well as Lacuna, but it is not generally authorized around the world. We arrived to most regulators saying we're operating at the same power levels as any terrestrial LoRaWAN device, the same duty cycles, and all these other constraints. The key point is most regulators did not envisage those bands being used to go to satellite. And as soon as we use the word satellite, they introduce a different department whose mindset is very much about licensing and regulation and authorization. And it does take quite a bit of lobbying to persuade these regulators that what we're doing is fine, legitimate, and doesn't interfere, and that we're not asking for any special protection in these bands. So it's a huge part of our work. It's a lot of our value. We have a very mature team doing this. We also have invested a great deal in spectrum monitoring over 6 years. So all of our missions have had spectral monitors as well. So we hold a global database, so we know exactly which channels are the preferred channels or the noisy channels to avoid in each country. And that's how we manage our constellation and choose the correct frequencies. We also do a lot of work with the LoRa Alliance, with other satellite vendors as well, to coordinate the lobbying towards these regulators. So I think this is probably an area where Lacuna can contribute a lot to UNISEC in these efforts. It's very important. I thought I'd finish. I think I'm doing okay for time, but I thought I'd finish with the obvious question: why wouldn't these use cases that have been proposed in all of these mission ideas, why are they not being deployed today using the vast array of existing satellite companies who are already out there and already provide very good services? And this is just a way of summarizing the general feedback we get when we talk to device makers and solution providers, ask them this question: why are you not using satellite today? And their list, and it's more or less in order of priority here, is legacy satellite systems are very high power and very large antennas, typically, and also directional antennas. So people are not aware that it's possible to reach satellites with 25 milliwatts and have multi-year battery life on these small sensors. The service is typically too expensive, always too expensive. And the same is true with terminals. Normally you're locked into buying a terminal, or at least the module from a particular vendor. And the market doesn't like that. There's sometimes regional limitations, as in a particular vendor or operator may not have license in a certain region. And there's a big movement now for a move to hybrid networks, so combining terrestrial connectivity with satellite connectivity. You see this in the handset market with direct-to-device movement that's going on right now. And legacy satellite systems just don't have this terrestrial interoperability. There are sovereignty concerns sometimes, and this could be in two ways. One is that some countries do not like the data to leave the borders of the country. And of course, LEO satellites, and especially store and forward satellites, by their nature, carry the data over borders. But it also might just be sovereignty in terms of capability. A lot of countries want to have their own sovereign capability, their own constellation for their own use. And then finally, the proprietary nature of legacy satellite systems. Of course, very much based on licensing and certain bands and certain solutions. So it's single sourced and you're locked to a particular vendor. And that's a big negative for scaling up of the IoT.
Okay,
So,
thank you. Thank you. Yeah, please complete.
I was just going to finish on this saying Lacuna solves these problems. These are all our mechanisms to address these various challenges, and I think I see the same in UNISEC's proposal. So hopefully this is very good validation that you guys are moving in the right direction. And I'll just leave this slide on the screen as we finish talking in case there's any questions. But I would finish with a call to action saying, why wait? You know, we're available now. The service is up there. Devices are on the shelf. It's a very good migration path to go from terrestrial LoRa to Lacuna's LoRa, and then presumably if UNISEC does adopt LoRa going forward, I don't know the answer, but you could have a very nice migration path so that you could be active now in preparation for a UNISEC constellation when it becomes available. And we fully make our own SDR payload available. Of course, we're a commercial company. It has licenses attached to it, but I think that would be a huge accelerator for UNISEC to standardize and join with the constellations that we already have available using the Lacuna technology. So I'll stop there. I'll say thank you and for your attention, and yeah, happy to take any questions.